In this tutorial, we'll learn about the Mermaid editor, a powerful tool for creating diagrams and flowcharts using simple, text-based code. By the end, you'll know how to write Mermaid syntax to visualize processes, sequences, relationships, and much more, all without needing to rely on complex graphical interfaces. A flowchart is a diagram that visually represents a process, workflow, or system, where different steps or actions are depicted using various shapes and connected with arrows to indicate the flow or sequence of operations. Each step in the process is represented by a symbol or box, and these symbols are connected by lines or arrows to show the directional flow of the process from one step to the next. The most common shapes used in flowcharts are rectangles for processes or actions, diamonds for decision points, ovals for the start or end of the process, and parallelograms for input or output operations. Flowcharts are particularly useful for illustrating complex systems in a simple and easily understandable way, breaking down a process into smaller, more manageable steps. In this flowchart, the process begins with start A. First, the code is written B. Afterward, the code is tested C. If a bug D is detected during the testing phase, the process loops back to the write code step B for debugging and fixing the issue. Once the code passes testing without bugs, it moves forward to deploy F. This flowchart represents a common cycle in software development, where writing, testing, and bug fixing are iterative steps, and the code is only deployed after it has passed all necessary checks. In the sequence diagram, the process begins with the user clicking a button in the front-end interface. This action triggers the front-end to send an API request to the backend, which is responsible for processing the request. Upon receiving the request, the backend performs the necessary operations, such as querying a database or performing a calculation, and generates a response. The front-end then receives the response from the backend and uses it to display the result to the user. This sequence of actions, from the user's click to the final display of the result, represents a typical interaction in modern web applications, where the front-end communicates with the backend to retrieve and show dynamic data. In this class diagram, the animal class is defined with a string name attribute to store the name of the animal, along with a neat method that represents an action common to all animals. The dog class inherits from the animal class, meaning it automatically has the name attribute and the eat method, while also adding its own unique method, play, which is specific to dogs. This relationship illustrates the concept of inheritance in object-oriented programming, where dog extends animal to inherit shared behaviors while introducing its own specialized actions. In this entity relationship ER diagram, we have two entities, user and order. The user entity has three attributes: int id to uniquely identify each user, string name to store the user's name, and string email to store their email address. The order entity contains four attributes: int id to identify each order, string name for the order description, date created to record when the order was created, and float total to store the total cost of the order. The relationship between these two entities is that a user can place many orders, meaning there is a one-to-many relationship between user and order, where a single user can have multiple orders, but each order is linked to one specific user. In this Git flow, the process begins with an initial commit on the main branch. From there, a new branch called feature is created, where additional work is done, and a commit is made to this branch. After completing work on the feature, the developer checks out the main branch again to ensure they are up to date. Another commit is made on the main branch. Finally, the work from the feature branch is integrated back into the main branch through a merge, completing the Git workflow. This flow illustrates a typical process of creating a feature branch, working on it, and merging it back into the main branch once it's ready. This pie chart, titled Time Spent Coding, visually represents how time is allocated across different activities in a software development process. It highlights the proportions of time dedicated to tasks like coding and debugging, which are essential parts of the development cycle. Additionally, other activities such as meetings involving discussions, project updates, and team collaborations can be included in the chart to show how communication and planning tasks fit into the overall workflow. By adjusting the chart, you can see how time is distributed between hands-on development work and necessary coordination efforts. This pie chart provides a clear visual snapshot of the balance between technical work and team interactions throughout the development process. This chart, titled Coding Hours per Day, provides a visual representation of how time is allocated to coding throughout the week. On the x-axis, you have the days of the week, from Monday to Sunday, and on the y-axis, you can see the relative amount of time dedicated to coding each day. The chart's bars show how coding time varies across different days, allowing you to observe trends in work habits, such as longer coding sessions on certain days and shorter ones on others. For instance, you might see that weekdays, like Wednesday or Thursday, tend to have longer coding periods, while the weekend might have less dedicated coding time. This chart is useful for identifying patterns, such as whether coding efforts peak at the start of the week or toward the end, and can provide insights into how time management or productivity could be optimized. Tracking these patterns helps in planning work schedules and making adjustments to improve efficiency across the week. This diagram represents a basic system architecture with three main components: the client, backend, and database. The client, such as a web or mobile app, interacts with the backend, which serves as the API server that handles requests and processes data. The backend then communicates with the database to retrieve, store, or modify information. This flow illustrates how the client sends requests to the backend, which processes these requests and interacts with the database to manage data. This structure is typical in many web applications, where the front-end client relies on the backend to serve data stored in a centralized database. Each connection, A, B, C, visually demonstrates the interaction between components, ensuring data is transferred and processed smoothly across the system. You have successfully completed the beginner tutorial for Mermaid. In this tutorial, you've learned how to create various types of diagrams, including flowcharts, sequence diagrams, class diagrams, entity relationship diagrams, and charts like pine bar graphs. You've also seen how to define relationships between components and how to represent data flow visually using simple code. Mermaid makes it easy to create clear, understandable diagrams using text, and now you have a solid foundation to integrate these diagrams into your documentation, project planning, or codebase.